Hello and welcome. My name is Bella Ponce and this is a video for my Math 310 portfolio. I will be doing a homework problem from problem set 3, number 4. The problem reads, 2 pitchers of orange juice are made. The orange juice in pitcher A is made with 2 cans of OJ and 2 cans of water. The orange juice in pitcher B is made with 3 cans of OJ and 4 cans of water. Which drink will have the stronger taste? Explain how you measure orangeness. Show 2 different solution strategies. Alright, so the first thing we want to do is write down what we know from what the problem tells us. And from this problem, we know that we're going to have 2 pitchers called A and B. Okay? And we know that pitcher A has 2 cans of OJ and 2 cans of water, W for water. So the first thing we want to do to make this simpler for us and easier to understand is we want to draw a picture, and we're going to start with drawing a picture for pitcher A. So I'm going to write pitcher A. And I'm going to use a circle for a can. So 1 can of OJ, just like this. Another can of OJ, label it. And then we have 1 can of water, another can of water. Now we're going to want to use some colors to help us get a little bit more organized. We're going to make our can of water blue. Our other can of water blue. And then our 2 cans of OJ will be orange. So we know that we have our 2 cans and we want to figure out which one is more stronger in taste, less potent, whatever you want to call it. So what we're going to do with our first strategy is we have 2 cans of water, and to help us divide equally the OJ up, we're going to split our OJ into 2 halves because we have 2 cans of water. So if we have 3 cans, we would have split it into thirds. If we had 4 cans, we would have split it into fourths, etc. We have 2 cans here of water. We're going to split our OJ into 2 halves. Okay. And then I'm going to want to mark that split line up just to make it clear that those are our 4 halves of OJ that we have. Okay. And now we're going to want to equally distribute the halves of OJ into 1 can of water. So 1 half will go here, another half here, 1 half here, another half here. So now with our special lines of distributing, we can see that 1 half, 2 halves of OJ will go into 1 can of water. 1 half, 2 cans of OJ will go into the other can of water. So now we're seeing that 2 halves of OJ go into 1 can of water. This is going to give us a ratio of OJ to water. We know that we have 2 times 1 half to 1 can. Or instead of saying 2 times 1 half, we can simplify it to be 1 to 1 ratio. So now we know that we're going to have, for every 1 can of OJ, we will have 1 can of water to dilute it or mix it, just like that. Alright, so let's write pitcher B down here. And pitcher B has 3 cans of OJ. So 1, 2, 3, label, and 4 cans of water. 1, 2, 3, 4. And now I'm going to color coordinate what our cans are. OJ is still going to be orange. And water will still be blue. Let's go back and just at the bottom label these blue cans are water cans. Okay, so like in picture A, we saw we had 2 cans of water, so we divided our cans of OJ into halves. We have 4 cans of water now, so we're going to divide our OJ into fourths. Just like this. Now our OJ cans are split into 4 because we have 4 cans of water. So let me use our pink highlighter again to show how we divided. And now we're going to equally distribute our fourths into the cans of OJ. So basically you want to go 1 can of OJ at a time and put them into a different can of water each time. So like this one will go here, then this fourth there, this one, this one. Now I go on to the next can. This fourth goes here, this fourth here, this fourth here, that fourth all the way over there. And then on the last can, 1 goes here, 1 goes here, 1 goes here, and 1 goes here. So now let's color coordinate our sharing. Go there, 1 go there. You don't really have to do this in any order. You just want to color and make sure you can see where all your lines are going. Anything I missed? Oh, yep, right there, and right there, and right there. Okay. So if we look back at picture A, we saw that it took 2 halves. We're going to go in each can of water. Now we see in picture B, it's going to take 3 1/4. See how there's 3 lines connecting? Those are 3 1/4 cans of OJ going into each can of water. Now let's write that out. So we can see these circles are showing that 3 1/4 cans of OJ will go into 1 can of water. Okay? And now we can write our ratio. So we'll do it again of OJ to water. And we know that we'll have 3 1/4 or 3/4 can of OJ and 1 can of water. Now we have our 2 ratios of picture A and picture B. Let's put our semicolon, or you can do it in a fraction form like this. So picture A was a 1:1. Let me scoot that over actually. We have a 1:1 ratio compared to picture B. We had a 3/4 to 1 ratio. So now since we have ones both for water, like it's a 1 can to 1 can for water in picture A and picture B, we can look at just the amount of cans of OJ. So picture B, we can see is going to have less amount of OJ in 1 can of water, and picture B is going to have more. Picture B is going to have 1/4 more cans of OJ in its mixture, because picture B only is going to have 3/4 a can of OJ. And since 1 is greater than 3/4, picture A will be stronger. All right. So, all right, now we're going to move on to our second strategy. Okay. So instead of using pictures for this one, I think it would be a good idea to make some ratios and just compare those straight off the back. So in picture A, for a ratio of OJ to water, we know that there's 2 cans of OJ to 2 cans of water. In picture B, we know for the ratio of OJ to water, we have 3 cans of OJ to 4 cans of water. And where we're going to go from here is we're going to try and make either the OJ cans the amount the same or the water cans amount the same. Right off the back, I can see that 2 and 3 both have a common multiple of 6. So I'm going to make the cans of OJ, instead of bringing it down to 1, we're going to push it up to 6 cans. So now we're going to have 6 cans of OJ, and we don't know how much water yet. We're going to have 6 cans of OJ in picture B. This way we can ignore the 6s when we're done and just kind of focus on the water to see which one is going to be more diluted. So now we can figure out how to get from 2 to 6, and we're going to make an equal proportion of ratios and figure out our missing value. So we know that we have 2 over 2 has to also be equivalent to the new ratio of 6 to we don't know. Well, 2 over 2 is 1, so whatever 6 is underneath or 6 is over, we're going to have to make this fraction right here, 6 over x, equal to 1. And we know that 6 over 6 is equal to 1. So our new water cans, we will have 6 cans of water when we have 6 cans of OJ. Now, this one's a little bit more trickier for picture B because it's not a 1-to-1 ratio. So let's make our equal proportions again. And we have first 3 to 4 of OJ to water. It has to be equal to 6 to another variable. We don't know. We'll just call this y. So to get from 3 to 6, we're going to multiply by 2. This is using the between method to find out our missing value in this equivalent proportion problem. So we're going to do the same right here. We're going to multiply 4 times 2 to get y. So 4 times 2 is going to give us 8. So this number is going to belong right here, and it's going to belong all the way up here. So we will have 8 cans of water. Now we can compare the two pictures. We have 6 over 6 compared to 6 over 8. So now we can ignore our 2 6s on the top and just see which one has more water diluting it. This one over here, picture A, has less water than it does in picture B. And the water is going to make it less strong because it's diluting the OJ. So since 6 is less than 8 cans of water, we know that more water will dilute. So picture A is stronger. So lastly, I just wanted to share what I liked about this problem. I really like it because of all the elements it includes. We have to draw pictures, we're using diagrams, we use some colors, we talk about division, fractions, ratios, equal proportions, and there's also different strategies students can use for this problem. You can even start going into the different methods for solving equivalent proportions. And yeah, that's it. Thank you for watching this video. I hope you enjoyed it.